Hello and welcome back to Bio 23, Infectious Disease. In this chapter, Chapter 4, we're going to be identifying the challenge and talking a little bit more about how microbes are spread around the world and what is increasing the risk of infectious disease worldwide and in the United States. The first thing that the book addresses is this concept of new or emerging infectious diseases and re-emerging diseases. Emerging infectious diseases are new diseases that have not been noticed significantly by the medical community worldwide. They seem to be new or relatively recent in human infections. Examples of these include Ebola in the last 100 years, the Zika virus even more recently, and MERS, or the Middle Eastern Respiratory Syndrome. Then there's a second class of infectious disease known as re-emerging infections. Re-emerging infections are diseases that used to be prevalent in the human population decades ago, seem to have disappeared for a while, but have recently reappeared in the human population. There are many reasons why a disease would have disappeared for a few years and then re-emerged, including antibiotics, vaccines, and others. Some examples of re-emerging infections include yellow fever, measles, whooping cough, multi-drug resistant MDR or extensively drug resistant XDR tuberculosis, and also multi-drug resistant gonorrhea. Of these re-emerging diseases, one of the more prevalent in the news today is measles. Measles was eliminated in the United States completely in the year 2000 and hadn't been seen for quite a few years, but has once now regained foothold in the United States and is on the rise in the US and Europe. The reason for this is that when people travel to other countries, they can become infected with measles, especially if they haven't been vaccinated against this disease. The reason why measles was initially completely eliminated from the United States was because people were uniformly vaccinated. But due to a decrease in vaccinations in human populations in the United States, we're starting to see an uptick in measles infections once again. Ebola is another one of these emerging and re-emerging infections. It was really widespread in the news in the year 2014 through 2016 because of its widespread disease transmission in Western Africa. For the first time ever, Ebola ended up spreading to a city that comprised over 2 million people. And because it was so easily transmitted between individuals, when it finally entered a city, it was able to transmit to many thousands of people. In the end, 28,000 people were infected with Ebola in the year 2016, leading to over 11,000 deaths, including many in the healthcare workers. This Ebola disease was even spread to healthcare workers that traveled back to the United States and Europe, leading to some transmission of Ebola in those places as well. Today, we can see infectious diseases are not only important in the United States, but also leading causes of death worldwide. Your book shares some statistics in this regard, and we can see that of the top 10 leading causes of death worldwide, lower respiratory infections is number 3 in the leading cause of death, diarrheal diseases is number 8, and tuberculosis is number 9. These are all diseases and deaths attributable to infectious disease. In the United States, we also have infectious disease as a contributor to a leading cause of death. Here we see influenza and pneumonia listed in number 8. And again, those chronic lower respiratory diseases at number 3. In addition to that, some of these cancers, specifically those caused for liver cancer and cervical cancer can also be caused by different infectious diseases, including hepatitis and HPV, respectively. In this chapter, your book goes through the main reasons why we see an increase in infectious disease today, including world population growth, urbanization, ecological disturbances, technological advances, microbial evolution and adaptation, and human behavior causes. We're going to be focusing on these different factors going forward. All of these different diseases can be affected in what's known as the disease triangle model. The disease triangle model focuses on three main aspects of the transmission and spread of disease. This includes a favorable environment that works together with promoting human pathogens growing and developing. The favorable environment is also going to work together with the human hosts. And in combination, the host, the pathogen or disease agent, and the favorable environment all contribute to the spread of infectious disease. One of the first factors that we're going to see in relation to the development and spread of disease is world population growth. World population growth has been accelerating in the last 100 years. It used to increase linearly or stay fairly stable, but in the last 100 years we've seen an explosion of population growth, of an exponential increase. The total human population numbers are not of concern necessarily when it comes to population growth. The biggest concern, in fact, is population density, or how many people are found in a given area. The more dense, or the more people in a given area, the more risk there is at the spread of disease. And that's because diseases can be transmitted from person-to-person contact, and with increased density, we see an increase in the person-person contact. In addition to that, we also see that population growth can lead to many other cases and other issues, including increases in vectors, which are organisms that carry disease from person to person, such as ticks, lice, mosquitoes, flies, and also animal to human contact, specifically in the case of rodents or bats and their interaction with people. Wherever we have dense populations, we're going to have an increased number of these. Also, as you can see from this figure in your book, an increase in human population growth also sees a change in behavior and activities, increased urbanization, changes in technological advancements, ecological disturbances, and advances in biology and medicine. And so many of the factors that we're going to continue to talk about in this chapter are also affected by human population growth. So at the core, you could say that the population growth really contributes substantially to a lot of the other factors that contribute to the spread of infectious disease. Other factors to consider when looking at human population growth is the age structure of the population. As individuals age, their immune system becomes weaker. And the older a population is, such as what we have in the United States with an increase in baby boomer populations, the weaker the overall ability to resist these infections becomes. This leads to the problem of immune suppression. The increase in world population is going to have another number of consequences that will foster an increase in infectious disease. In addition to increased person-to-person contact, we're also going to see a change in climate change, which could expand habitat ranges of various infectious disease vectors, as we'll talk about later. We're also going to see a larger number of travelers that could transmit the disease even further and more frequently. More frequent wars and accompanying infections, greater disease associated with refugees and displaced persons, overcrowding in major cities, increased construction of dams, irrigation projects, and deforestation that will increase the range of infectious disease vectors that we'll talk about later as well, and also that increase their proximity to human populations. Increase in population growth also lead to more people living in poverty without proper sanitation or access to healthcare, increased hunger and malnutrition, increased loss of potable water supply, and other issues. One of these major factors that we see as a general trend with increased population is urbanization. Urbanization began as a general trend starting in the early 20th century, and we're seeing more and more people move to the cities. In fact, over half of the human population now lives in cities. Many of these cities are associated with increased poverty, although that is not a definitive connection between the two. If you take a look at Table 4.2 in your text, most of the cities that are listed there have an increase in poverty compared to rural populations of those regions, with one glaring exception, and that's Tokyo, Japan. However, generally, urbanization is associated with poverty. The problem with urbanization and poverty is manyfold. There's a drain on natural resources, which means access to fresh and clean water sources is going to be limited, and contamination of soils is also going to increase as human feces and other transmissible diseases can be stored there. We're also going to see a decrease in public health infrastructure, including sanitation, rodent increases, and immunization problems as well, and malnutrition, which accompanies decreased immune system strength and overall health, which can also lead to an increase in infectious diseases. However, keep in mind that this is not a bygone conclusion. Remember that Tokyo, Japan, and even in New York, United States, living in the city does not automatically mean that you're subjected to these various problems. It is a general trend that urbanization leads to increased poverty and these increased infectious disease risks, but it is not always going to occur. It really depends on the economy of the government and the population in that location. Increased urbanization can also lead to air pollution problems and changes to the ecosystems of that location. Air pollution attributes or is accountable for almost 3 million deaths every year. And this increased air pollution, which is a result of particulate matter in the air, can also cause weakening of the lungs and respiratory system, which can lead a person to become more susceptible to infectious diseases that way as well, increasing the death rates from air pollution even more. In the next section, we're going to talk about the changes to ecosystems, partly as a result of urbanization, but also partly as a result of human behavior, and talk about how these can impact infectious disease transmission as well.